welcome to Distance Learning Math 3. First of all, quick announcement. As far as our ability to interact, I wanted to live stream the lessons, but the resolution was too poor. It wasn't going to work. You wouldn't be able to actually see any of the writing, which kind of makes it useless. So I'm forced to record myself. Here's our first recording. That being said, obviously you're probably going to want to ask some questions. So what we're going to do is office hours, which basically is like flex time. And we're going to do that via a Google Meet. So I will push out a link for the Google Meet through Canvas. I might also push it out through Google Classroom, but a lot of you guys, when I tried to set up a Google Classroom, had emails that bounced back. I'm assuming you all have a Canvas account successfully. So I'm going to post these videos on Canvas and push our links out through Canvas as well. Feel free to talk to your friends and make sure that they are also on Canvas, and anyone who isn't, tell them to get on Canvas. Okay, so anyway, our office hours or flex time for Math 3 will be A-days between 12:30 and 1 o'clock. B-days between 8 and 8:30. Now, if you're a B-day student and you can make the A-day time, that is fine. If you're an A-day student and you want to show up during the B-day time, that is also perfectly fine. Moving forward, we're going to call tomorrow, Wednesday, an A-day. And we're going to call Thursday a B-day. So feel free to show up to either one, or if you have multiple questions that pop up, you can show up to the A-day and then show up again on the B-day time. That's perfectly fine, not an issue. And feel free to collaborate with one another as well. Also, I foresee an issue with microphones. If everyone signs in and you all have your microphones on and there's a lot of noise in your rooms, it's going to be a mess. No one's going to be able to hear anything. So please, let's start. Everybody microphones off and type things into the chat box, and then maybe we will have, if you have a question and you can't type it well, then we'll have you turn your individual microphone on, ask your question, and then you can maybe turn your microphone off, because we don't want to have 60 people all with background noise broadcasting at the same time. That would be a mess. So again, start with your microphones off and we'll adjust from there if need be. Okay, so this video, we're going to cover our second day of Law of Sines. So on Canvas, you should have the handout, the 5C.4 handout that says Law of Sines Part 2 handout. I've worked it out here. I'll post this on Canvas along with this video explanation. So this video, I'm going to start with the new lesson. I'm going to post a separate video where I cover warm-up problems. And also, of course, you can ask questions on any of this during our Google Meets. Okay, so jumping down to the lesson. Last time we talked about how we can show congruence with triangles. And hopefully you remember, we said there's kind of an issue when we're given side-side angle, right? We said that we can't show congruence using side-side angle, but then we actually solved some triangles with that information given. The catch was, as I mentioned in class, we always give you an angle that was obtuse. So if I have side-side angle with an obtuse angle, it's all good. I don't have to worry. But today's lesson, what if I have side-side angle and the angle given is acute? So I've done my best to draw this situation. So I'm given this side of 12. I'm given another side, in this case, length 30. And then I'm given an angle right here that is an acute angle. I didn't measure it. What do you guys think? Looks like about 15, 20 degrees. We'll just pretend it's 15 degrees. Okay. So I have side-side angle. My given angle is an acute angle. Here's the dilemma. When I draw my triangle, I have what you see here in black. This black triangle uses side 12, side 30, and the given angle. But notice, I also can draw this green triangle. Side 12, side 30, given acute angle. So there's two different triangles that I could draw here. And that's why we call this situation the ambiguous case. Because I can't show congruency. There's two possibilities. Okay, so today's lesson, we're basically going to sort through how do I know from the information given what I have. So if we look down at the bottom of the sheet, it's calling this side, by the way, this is R, so this would also be possibly R. They're calling this side S. I wish Mr. Nguyen had picked a different letter because that looks like a 5, but it's an S. And then this angle, they have it labeled as R. All right, so at the bottom it says if R is equal to H, H being the height of my triangle. Okay, notice now if R is equal to the height, I can no longer flip it, swing it out, or swing it in. There's only one possible triangle because as soon as I try to change the angle up here, H wouldn't be long enough to reach any longer, right? And if I move it this way, H again won't be long enough to reach. So if R is equal to H, I actually have a triangle that's a right triangle. And I would have this triangle right here. So that's what we're going to write. We'll have one right triangle. Okay. Well, what if R is less than H? Okay. So imagine if this side was shorter than H. Right? It doesn't matter how I rotate it, what angle I try to pick, it's just plain not going to reach this base. I can't create a triangle if R is less than H. H is the absolute minimum length that I would need to complete this triangle. So anytime I find that R is less than H, there's no triangle possible. Okay. So those are actually the two easy situations. Whenever R equals H, easy, one right triangle. Whenever R is less than the height, can't have a triangle. Then we get to the ambiguous case, which is what I've drawn here. R is longer than H, right? So if R is greater than H, we definitely have at least one triangle, but we might have two. So we'll have one or two triangles. Okay. Now, how do I know if I have one triangle? How do I know if I have two triangles? Well, that's the next section. Once this happens, okay, once R is greater than H, I now have more questions to ask, okay? If side R is equal to side S, so in other words, if these two sides are equal, if I tried to flip this over here this way, R would land right on top of S, and therefore no triangle. So if R is equal to S, it has to go this way, and I would have an isosceles triangle. So whenever R is equal to S, I'll have one isosceles triangle. Okay. Also easy, only one triangle. Now, what if R is greater than S? So let me pick up the yardstick. So I made S 30. Imagine if R were longer than 30, right? I could only come out this way to create my triangle. If I try to go back this way, it won't work. So anytime R is greater than S, I will only get one triangle, and R must be swung out. It has to run this way. So I'll have one triangle with R swung out. Okay, and then that leads us to our last choice. If R is less than S, and that's the one I drew up here. R is 12, S was 30. When that happens, I have two choices. R could be swung out, or R could be swung in. Two possible triangles, both 12, 30, and acute angle. That's SA. So two triangles will exist. R can be swung out or swung in. So that's the gist of what we call the ambiguous case. You have to basically start going through all of these questions one at a time to figure out what you have. Do you have one right triangle? Do you not have a possible triangle? Or do I have one isosceles triangle? Do I have one scalene triangle? Or do I have two triangles? Right? And that's the order that you go through these problems. So the big question, you can see, first I compare side R to the height, H. So how do I find H? Do that in another color. Well, the good news is, here's H. H creates a right triangle. Okay? And I have angle R, right? I have this angle. So I can simply use right triangle trig, right? SOHCAHTOA. I also have the hypotenuse. I'm looking for the opposite side. So the trig function that uses hypotenuse and opposite side would be sine. So if I do sine of angle R, it's going to equal the height, we're calling H the height, not the hypotenuse, divided by the hypotenuse, or S. So solving for H, we find the height of the triangle will be equal to this side multiplied by sine of our given acute angle. All right, so I'm going to go ahead and flip it over, and we'll try some of the problems together on the back. I'll leave this up here because we want to refer to it again. All right, so problem A. Okay, we're given an angle, it's acute. Given a side and another side. Okay, so step one, we want to find that height. So let's go ahead and draw this. So this is going to be 40 degrees. We have, that's A. We have a side opposite A, this is 12. And then we have, this is 15. Okay. So our first step, let's find that height. So using sine 40 degrees will equal this height divided by 15. So my height will equal 15 times the sine of 40 degrees. Now again, when you do this, please make sure your calculators are in degree mode. So your calculator should have a D or a DEG on the screen. And so sine of 40 times 15, I get 9.64 approximately. So now I'm going to compare that to this side over here, right? If this side over here isn't at least 9.64, it can't reach to form a triangle. But it's actually greater than 9.64. So that's where we're at. R is greater than H. So we either have one or maybe two triangles. So we move on to our next set. Does R equal S? Right? Here's R, here's S. Are these two numbers equal? No. So we're not an isosceles triangle. So then I look over here. Is side R greater than side S? Is 12 greater than 15? Nope. So I don't have a scalene triangle. I have R is less than S. That's when I can have two solutions. So I'm going to have to find both solutions. Every year students will find one of the two solutions. They'll pat themselves on the back and say, yay, good for me. But you've only done half the problem, so you'll get half credit. You must find both triangles when two triangles exist. So let's go ahead and find both triangles. So I'll erase that. I now know where I'm at. I am right here. Two triangles exist. Okay, so for my first triangle, I have the information for law of sines. I'm going to change back to black. Okay. So sine of 40 degrees over 12 has to equal sine of this angle over 15. What was that angle? That's going to be angle B. So sine of B over 15. Now I solve. So sine of B equal 15 times sine of 40 degrees over 12. Inverse sine. Okay. So again, calculator, make sure you're in degree mode. And I'm getting a very small angle, 0.8 approximately, 0.803. Okay. Oh, I'm sorry. I forgot to inverse sine that. I was like, that's why I stopped there for a second. That didn't make sense, right? Remember our rule, our longest side has to be opposite our greatest angle, but that wouldn't be the greatest angle. And that's because I forgot to take the inverse sine of 0.083. That's better. Okay, so B could be 53.5 degrees. Okay, and sure enough, that is larger than 40 degrees. So it could be that this is 53.5 degrees right there. Now, I need to find my other angle up here, which is pretty simple. 180 minus those, right, will give me angle, I guess that's C. And let's see, that's, so that gives me 86.5 degrees. And lastly, find side C. So again, law of sines. Please leave more decimals in your calculator when you're doing this calculation, because if you round off, it'll create round off error as you work with that rounded off number. So C is going to equal, I'll show the work. So C sine 40 degrees equal 12, sine 86.5 approximately. So C equals 12 sine 86.5 degrees over sine 40 degrees. Okay, working that out. And again, I'm using the number that I had stored previously, the 86.5 blah, blah, blah. I have it left in my calculator from the last calculation, so I can just use that. And working off of that, okay, I'm going to get, the C is 18.6 approximately. Now, I go back and double check. My largest side is side C at 18.6. Is it across from my greatest angle? Angle C is, yes, my greatest angle. Okay. Then I go back and I say, okay, my smallest side's right here, 12. Is it opposite my smallest angle? Yes, it is. Are the sum of my two shortest sides, 12 plus 15, does that exceed my longest side? Yes, it does. So this triangle makes sense. It passes all of our triangle theorems. Now, that's where students tend to pat themselves on the back and move on, but there's another triangle possible. So we have to find that second possible triangle. What if this 12 actually swung in like that? Okay. Here's the good news. The triangle that I just drew right here, that's an isosceles triangle. So that means that this angle must equal this angle. Okay. So if this is 53.5 degrees right here, I could find that angle by subtracting from 180. Okay. So this is how I start my second solution. I'm going to take 180 minus the 53.5, and that's going to give me a different choice for angle B. So angle B that angle would now be 180 minus 53.5 degrees. So that gives me 126.5 for angle B. We should have more room. So now to find angle C, I would do 180 minus this minus 40. I'm going to go ahead and erase. So angle C, 180 minus 126.5 minus 40. So that's going to give me approximately 13.5. Now for my sides, I'm going to use off sides. So sine 40 degrees divided by the opposite side, 12, will equal sine of 126.5 degrees divided by, oh, I already have the 15. Didn't need to do that. We just have to find the side here, which is opposite angle C. So sine of 13.5 degrees over C. Solve that for our last bit of information. And again, hopefully you've left, when you calculated this B, you left all those decimals in there, and you subtracted it from 180 with all those decimals, and then you subtracted 40, and so you still have all these decimals left in your calculator, and then you can do sine of that 13 point blah, 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 multiply it by 12, divided by sine of 40, and then you'll get C with perfect accuracy. If you do it, you should get 4.36. So now, double check that this triangle works, that it makes sense. Okay. So my largest angle was angle B, and that's across from side length of 15. That's the longest side on this particular triangle. My smallest angle is here, angle C at 13.5, and it is across from my shortest side. Now my two shortest sides, when I add them together, they exceed the length of my longest side. So yes, indeed, this forms a triangle. And there you go. That's how we find two triangles when we have SSA, side-side angle. Okay. Feel free to pause now, and you can go back and review that solution if you need. I'm going to move on and do problem B. All right, problem B. And yeah, these are inches. I neglected units on the last one. Feel free to put the units in. Okay, so step one, I need to figure out, I have side-side angle. I need to figure out what's R in relation to the height of my triangle. So I'm going to draw my triangle again. 40 degrees again. Let's see. 12 over here again, but this time B is 10. Okay. So I have a little bit different situation already. But we need to find height, because that's the first question we need to answer. What's my height? So sine of 40 degrees will equal the height divided by 10, the hypotenuse. Okay, so height is 10 multiplied by sine of 40, which is 6.43 approximately. Okay, so I then ask myself the same question. Is my height equal to this side length? No. Is this side length less than my height? No. Is this side length greater than my height? Yes, right? So I landed right here again. Now, when that happens, I now have to compare this side length to the other given side length, okay? So in this case, this side length is 12, the other given side length is 10. So R is greater than S. When that happens, good news, there's only one possible triangle, okay? So I didn't draw this to scale. This side right here is actually longer than that side right there. And since it's longer, let me redraw it. Okay. So since this side is longer than that side, I can't swing it back in and create a triangle. It's too long. Not going to work. So I now know I have exactly one triangle and only one triangle. So let's solve it. Again, law of sines is the appropriate choice because I have an angle in the opposite side. So sine of the angle divided by the opposite side will have to equal sine of, I didn't write that one down, that's B. Sine of angle B divided by 10. Solving that. So angle B will be inverse sine of 10 times sine of 40 degrees over 12. Again, make sure you're in degrees, and also make sure after you calculate this that you do inverse sine. We should get 32.4. Okay. So that's 32.4. To find our missing angle, we can now subtract from 180. So A is going to have to be 180 minus 32.4 minus 40 degrees. So work that out, and we're going to get 107.6 degrees. And now we just have to find side A. So again, law of sines. Use our given. It's better to work off of the given clean angle than to work off of angle B that we rounded off. Okay, so work off the givens whenever possible. So I'm going to do sine of 40 degrees over 12 equals sine of A. Again,